So the last aspect of water quality monitoring is knowing whether your water treatment system is working. So one way to test that is to monitor before and after treatment in the irrigation line using these Petrifilms. Here we have 6 different greenhouse nursery locations. They're all chlorinating in this case. Chlorine bleach, which is a liquid, gas, or tablets, calcium hypochlorite. This is their water source, municipal pond, well. Okay, this is the bacteria count before the treatment, before the chlorination, and after the treatment. So you can see, for example, that location B had very high counts before treatment, and the chlorination was very, very effective. But let's look at location F. This is the only location where we did not get adequate control. After treatment, we're still well above 10,000 colony-forming units per milliliter. What was different about this grower? They did not have a filtration system, so the organic load level was too high. Now, as well as measuring the bacteria counts as an indicator of biological load, you can also directly monitor active ingredients. And in the handout, there's some work that Dr. Jinshen Wong and my team done to give you some guidelines of different kinds of kits that you can use. There's also a particular discussion of ORP, oxidation reduction potential, particular kind of meter that can be used with some of the sanitizing agents. So there are kits available for all of these different active ingredients. In our experience, when we visit nurseries, they're almost always underdosing. If you overdose, you can cause phytotoxicity or even worker safety hazards. So monitoring on site is very important. Rosa Raudales and my team has got a neat little tool where it's a summary of research data. Here you go to Grower Tools, Waterborne Solutions. And let's say we pick one of the pathogens or targets that are listed there. This research work, this tool summarizes published work where plant pathologists have run trials under lab or field conditions and looked at different concentrations of different sanitizing agents and their level of control for these pathogens. So that can be a way of comparing your levels in your greenhouse with what research has shown being required for adequate sanitation. I mentioned ORP, oxidation reduction potential. Here's some research work from Colorado State University. This is the free chlorine concentration in parts per million. This is the percent mortality of Pythium aphanidermatum zoospores after 2 minutes. In this experiment, the pH was either acidified down to 6.2 to 6.6, or it was allowed to increase up with the addition of the chlorine to 7.7 to 8. So you can see that there's much better mortality at a low chlorine concentration when the pH was low in the target range. If you are chlorinating, you almost certainly should also be injecting acid. What they also did in this experiment, which was interesting, was to measure this oxidation reduction potential, these numbers here. Okay, so the ORP meter works like a pH meter. And if you can see that if they had numbers around 720 millivolts or higher, then they had a very good level of control of Pythium zoospores. So an ORP meter, which is sometimes put in line when you're chlorinating, can give you an idea of the sanitizing power of chlorine, of ozone, or of chlorine dioxide.